To achieve accurate and safe pipe bending, there are several general tips to keep in mind. Firstly, use a level to ensure the bender is straight and level before bending. This provides a stable foundation for consistent bends. Secondly, secure the pipe firmly in the bender using clamps or chains. A secure grip prevents slippage and ensures accurate bending. Thirdly, apply slow, steady pressure when bending to avoid kinking or collapsing the pipe. Rushing the process can lead to imperfections. Fourthly, consider heating the pipe to a temperature between 600 and 800 degrees Fahrenheit, which is 316 to 427 degrees Celsius, for easier bending. This is especially helpful for thicker pipes. However, always follow the manufacturer's instructions, as excessive heat can weaken the pipe. Fifthly, lubricate the bending die with oil or grease to reduce friction. Lubrication ensures a smoother bending process. Sixthly, check bends frequently using a protractor or angle finder. Regular checks help maintain accuracy and prevent overbending. Now, let's delve into some specific tricks for pipe bending. Firstly, practice with scrap pipe. Use leftover pipe to practice different bends before attempting actual work. This allows you to get a feel for the bender and the materials. Secondly, measure and mark the bend location. Accurately mark the desired bend point on the pipe to ensure precision. Precise measurements are crucial for achieving the desired outcome. Thirdly, use a string line. Stretch a string line between the bender's central axis and the end of the pipe to guide the bend and maintain accuracy. The string line acts as a visual aid. Fourthly, bend in stages. Divide large bends into smaller increments to minimize strain on the pipe and bender. This prevents overstressing the materials and equipment. Fifthly, backbend to fine-tune. After the initial bend, reverse the bending direction slightly to fine-tune the angle. Backbending allows for precise adjustments. Sixthly, cool the pipe slowly. Once the bend is complete, allow the pipe to cool slowly to prevent warping or cracking. Rapid cooling can compromise the integrity of the bend. In addition to the above, consider the following advice. Firstly, always wear safety gear. Use eye protection, gloves, and earplugs while operating the bender. Safety is paramount. Secondly, inspect the bender regularly. Check the dies, clamps, and other components for wear or damage. Regular maintenance ensures the bender operates safely and effectively. Thirdly, use the right materials. Ensure the pipe is compatible with the bender and that the bending dies are appropriate for the pipe diameter and material. Using incompatible materials can damage the bender or the pipe. Fourthly, always follow the manufacturer's instructions. Refer to the bender's manual for specific operating procedures and safety precautions. The manufacturer's instructions provide essential guidance. Finally, consider seeking professional training. Attending a training program or consulting with an experienced bender operator to improve your technique is extremely helpful. Now, let's talk about some potential problems you might encounter while using a pipe bender and how to avoid them. One common issue is kinking or collapsing of the pipe. This usually happens when the pipe is not properly supported or when too much pressure is applied too quickly. To avoid this, ensure the pipe is firmly secured in the bender and apply pressure slowly and steadily. If you're bending a thin-walled pipe, consider using an internal support, like a mandrel, to prevent it from collapsing. Another issue is wrinkling on the inside of the bend. This can occur when the bending die is not properly lubricated or when the pipe is not heated sufficiently. Make sure to lubricate the die with oil or grease, and if you're working with a thick-walled pipe, consider heating it to the recommended temperature. Also, ensure that the bending die matches the pipe size. Overbending is another problem. This happens when you exceed the desired bending angle. To avoid this, check the bend frequently using a protractor or angle finder. Bend in small increments and use backbending to fine-tune the angle if necessary. If you're using a powered bender, be very careful not to overbend. Spring back can also cause problems. This is the tendency of the pipe to return slightly towards its original shape after bending. To compensate for spring back, you may need to overbend the pipe slightly. The amount of spring back depends on the material and the bending radius. Experiment with scrap pipe to determine the appropriate amount of overbending. Flattening of the pipe can occur if the bending die is worn or damaged, or if the pipe is not properly supported. Inspect the bending die regularly for wear or damage, and replace it if necessary. Also, ensure that the pipe is firmly secured in the bender. Cracking of the pipe is another concern, especially when bending brittle materials. To avoid cracking, heat the pipe to the recommended temperature and bend it slowly and carefully. If you're working with a brittle material, consider using a bender with a larger bending radius. Improper alignment can also cause problems. Make sure the bender is straight and level before bending, and that the pipe is properly aligned with the bending die. Misalignment can lead to inaccurate bends or even damage to the pipe or bender. Slipping of the pipe in the bender can be a challenge. Ensure that the pipe is firmly secured in the bender using clamps or chains. If the pipe is slipping, try using a different type of clamp or chain, or roughen the surface of the pipe to increase friction. Inconsistent bends are another problem. This can be caused by variations in the material, or by inconsistencies in the bending process. To minimize inconsistencies, use pipe from the same batch, and follow the same bending procedures for each bend. Also, make sure the bender is properly calibrated. Damaging the bending die is possible if you use the wrong die for the pipe size or material. Always use the correct die for the pipe you are bending. If you're not sure which die to use, consult the manufacturer's instructions. Also, avoid using excessive force when bending, as this can damage the die. Here are some more specific techniques for different types of bends. For creating offsets, which are short bends used to move a pipe around an obstacle, accurately measure the distance you need to offset the pipe. Use the appropriate bending die for the offset angle you need. Bend the pipe in 2 stages, creating 2 equal bends in opposite directions. Ensure that the 2 bends are aligned correctly to create a smooth offset. For creating saddles, which are bends used to go over an obstruction and return back to the original plane, measure the height and width of the obstruction. Use a sequence of 3 or 4 bends to create the saddle. The center bend should be at the highest point of the obstruction, and the other bend should gradually slope the pipe back down to the original plane. Ensure that all bends are smooth and aligned correctly. For creating 90-degree bends, which are commonly used to turn corners, measure the desired bending radius. Use a bending die that matches the bending radius. Bend the pipe in a single stage, applying slow, steady pressure. Check the bend frequently using a protractor or angle finder to ensure that it is exactly 90 degrees. For creating segmented bends, which are used to create large radius bends, divide the bend into several small, equal segments. Bend each segment slightly, creating a series of small, gradual bends. Ensure that all segments are aligned correctly to create a smooth, continuous curve. This technique is often used for creating bends in large diameter pipes. When working with rigid metal conduit, or RMC, it is important to use a bender that is specifically designed for RMC. RMC is a very strong and stiff material, and requires a more powerful bender than other types of pipe. Heat the RMC to the recommended temperature before bending. This will make it easier to bend and prevent it from cracking. Use a shoe-type bender for RMC bend. These benders have a shoe that supports the pipe and prevents it from collapsing. When working with electrical metallic tubing or it is important to use a bender that is specifically designed for EMT. EMT is a thin-walled material and can be easily damaged if it is not properly supported during bending. Use a Hickey-type bender for EMT bends. These benders have a hook that grips the pipe and provides support. Avoid overbending EMT, as this can cause it to kink or collapse. When working with PVC conduit, it is important to use a bender that is specifically designed for PVC. PVC is a thermoplastic material and can be easily bent when heated. Use a hot box or a heat gun to heat the PVC before bending. The hot box is a temperature-controlled container, and the heat gun is a tool used for applying hot air. Use a bending shoe that matches the size of the PVC conduit. Avoid overheating the PVC, as this can cause it to become brittle and crack. Here are some tips on maintaining your pipe bender. Clean the bender regularly. Remove any dirt, debris, or grease that may accumulate on the bender. Lubricate the moving parts of the bender. Use a light oil or grease to lubricate the pivots, hinges, and other moving parts. Inspect the bending dies for wear or damage. Replace the dies if they are worn or damaged. Check the clamps or chains for wear or damage. Replace the clamps or chains if they are worn or damaged. Calibrate the bender regularly. Use a protractor or angle finder to check the accuracy of the bender. Adjust the bender if necessary. Store the bender in a dry place. This will prevent rust and corrosion. By following these tips, you can ensure that your pipe bender is in good working order and that it provides accurate and reliable bending for many years to come. Remember to always consult the manufacturer's instructions for your specific pipe bender model.